Okay, friends, so it might help to get more of a visual of this whole idea of sensitivity and specificity, and also the ideas of false negatives and false positives. We'll start with the sensitivity. Let's imagine 100 people that all have a certain disease. Which disease doesn't matter, so just some anonymous disease. And then all 100 of them take the same test to try to detect the disease. Now let's suppose this test has a sensitivity of 75%. That means that if you have the disease, there's a 75% chance the test is going to come back positive. Check this bit out here. If you have the disease, that's what makes this a conditional probability. Okay, so of these 100 people, 75 of them are going to get true positive test results. But what about the other 25? Well, they took the test, so they're going to get a result. They're not going to get a positive result. They're going to get a negative result. But since they have the disease, that means the result is falsely negative. I'm going to shade them red because their test was incorrect. And we're going to say this test has a false negative rate of 25%. So that's why the sensitivity and the false negative rate are complementary. They have to add up to 100%. But that's assuming these 100 people actually have the disease. What about people that don't? Okay, well, let's start again with 100 people. But none of these 100 people have the disease. Now, they don't know that, so they go and take a test to find out if they have it. Now, this test is going to have something called a specificity. Specificity is nothing more than the chance of a true negative. Why don't they just call them true positives instead of sensitivity and true negatives instead of specificity? I don't know. But the terms are used. And that's the whole point of this video, is to try to make sense of them. Okay, so the specificity needs to have a percentage. So let's give it one. Let's say the specificity of this test is 95%. That means that if you don't have the disease, 95% of the time, the test will tell you you don't have the disease. Just a quick note, these numbers for sensitivity and specificity aren't just pulled out of thin air. The labs that create the test establish them through data collection. Okie doke, so we have 100 people that don't have the disease. 95 of those 100 are going to get negative test results. So I'll shade them green because that's correct. But how about these 5 folks over here? We know they don't have the disease. We know they took the test and the test didn't come back negative. That means the test must have come back positive for them. But they don't have the disease, which means the test is falsely positive, which means the false positive rate of this test must be the other 5%. All 100 of those people do not have the disease. 95% of the time, the test is going to tell them they don't. The other 5% of the time, it's going to incorrectly tell them they do. To sum up, the sensitivity and the false negative rate have to be complementary, and the specificity and the false positive rate have to be complementary. If you're not a fan of the phrase sensitivity, you can replace that word with true positive rate. And similarly, if you don't like specificity, you can replace that with true negative rate. I hope this video helped to demystify those ideas for you a little bit.